Yo, good morning, good morning. So this is what we're gonna continue doing today, screen space reflection, and I'm just gonna jump right into it. We currently have it in a pretty good state, but we still have a few artifacts I want to try and minimize or improve upon. I think the biggest one, which should hopefully be one of the easier to fix, is the banding of objects further away from the camera. So we pretty much have no banding here. I wonder if, yeah. So, and it has to do with step distance and such. So the point here is that if we don't find an intersection, so on black frames we don't, or black pixels we don't find an intersection, what we're gonna do then is we're gonna do a second pass where we take the point that was closest to an object. Although I wonder, yeah, we're gonna take the point on the ray where we were closest to an object, and we're gonna do a second pass there where we are a little bit more, or we look for an intersection a little bit more thorough. Yes, but before we do that, we're gonna do, so a lot of the calculations we do here we're gonna do multiple times. So we're gonna do a custom struct, and we're gonna put a lot of this data in that struct, and yeah. So we're gonna do struct then we're gonna call it screen space ray, and I wonder what do we want to send in here. So we're gonna define this as so the 2 points in view space and so the 2 points in view space and screen space. So we're gonna have float 2 Yo, what's up, Robert Patterson? What is your opinion on things? Be more specific, please. Is generated a mesh? I don't follow. It's too early. So screen space ray Robert Patterson, I mean, I just generated a mesh. Am I cool already? Dude, generating meshes is incredibly cool. So yes. I wonder what we need here. Ray direction, ray endpoint. Let's just, I wonder if we just want to do float 3 start SS or start VS direction VS. I think this might be everything we need. But then we're gonna have to do we probably want to do this. So ray start point, ray direction, and then we're gonna do, so we're gonna do ray dot start VS is equal to start VS. And then we're gonna do ray end VS is equal to we want length as well. And then we want to we want to do some extra calculations for the length. We don't want it to go behind the near clip plane. So ray nvs.z projection params. Yo, what's up, Gustas? Yes, we're going to do it like this. So that means that we have done, we do this and we do this. And now it's time to calculate the points in screen space. So we just do start screen space is equal to we have float 2 here, so let's do And then we want to do the exact same thing with the end. Oh, did I actually... but here we want end SS. And here we want ray.start vs ray.end vs. So start vs, end vs, start ss, end ss. So that means we have done these four as well. I wonder, I don't think we use this one, so we can skip it. Then we have these. I don't care about these. Yeah, so delta step. I don't think I want to keep that in ray here. So what we're gonna do is screen space ray is equal to create screen space ray, and we want to have the start point, and that's just gonna be this. We want length and direction as well. So we're gonna do it like this. Start, direction, and length. So now we have a ray here instead. Delta step length ray end SS ray. We're gonna do it like this. One sec. I want to keep this one. Okay, I just want to double check one thing. HLSL struct constructor. Fuck it. Create screen space ray, and then I'm wondering if we're gonna keep it like this. Delta pixel delta. Okay, that's good. Current point. Yeah, we're gonna do this a lot. Probably want... I wonder if it's only... It's depth difference that is the interesting part here. Do want current point as well. That's not true. Create screen space ray, and then we're gonna get bool calculate scene view depth difference for ray. And what we want to send in is something like that. And then I think, yo, good morning, Geralt. I also want to... We can probably pack more information into this later on. Out float depth difference. Okay, so we did something similar yesterday. Fuck, we do want current point. That sucks. Outfloat depth difference. We're gonna do out float to ray point ss. Ray point ss is equal to step count times step direction. So then we want to do the first check. So this is if the ray current point ss let's just call it point ss. So if the point moves outside of the screen, we want to return false here. We're going to do a second check like this related to t. So if we have walked along the full the full ray, we also want to return false. Actually, we don't need to do XY here because this one is a float 2. Start SS, end SS, ray current point SS. So here we just do point SS. So that's our T, and here we want to do something similar. If T is bigger than 1, so we have walked along the full ray. Am I missing a... I don't think so. Okay, so here we return false as well. So this is, if this one returns false, we don't get a depth difference because we have moved to the end of the ray pretty much. Then we want to calculate ray depth in view space. We want to get scene depth in view space. And then we want to return depth difference. So it's going to look like and this is actually point depth in view space. Point depth vs point depth scene, or actually point depth vs scene depth vs. And then we do depth difference is equal to and return true. Okay, so let's see here. We're going to define up here, we're going to define call it scene view depth difference. And I also want to do float ray point SS. So this we do inside the method, this as well, this as well, this as well. Fuck it, we're gonna remove this one as well. So here we do if calculate scene view depth difference for ray. Did I create the ray? No, I didn't. Oh yeah, we did. So ray, then we have step direction, step count, ray point, and then depth difference. So ray point SS and scene view depth difference. I think I want to return a not here, and we're gonna do break. Otherwise, fuck, let's rename this one, make it a little bit shorter. So if depth difference is bigger than 0 and less than thickness based on distance x, then we return this. Otherwise we're gonna do this, yes. And let's see if we have something that works or if we fail. Point SS at line 130. Yes. Damn, I missed a lot of... There we go. Ray current point SS. Here we want ray point SS. Okay, so we have a working shader at least, but we're not getting any result. Do we need to do... 0.05 should be okay. Do we have any hit? No, we don't. Okay. If this value stands, we should enter this one every time, so if this one returns false, we want to break. Do we return false, return false, return false, return true? What am I missing here? Input position VS, we reflect it. Minimum. So this one should be created correctly. We do negative in front here, so that should be okay. It could be the fact that we break too early, i.e. Yeah, it could be. So I wonder if it's the fact that this one we always return false here. If I want to do return Okay, so the fact is this one always fails. Why? Step, yeah, it's step we want to do, step count. Isn't this how we want to do it? Out. Let's do. Yeah, we don't want to send anything in here, so this should be correct. Okay, how can we test this? We can do. Step direction, step count. Waypoint SS. Should be okay. What am I missing? Okay, let's do it like this. depth difference is equal to 0, and depth difference is equal to 0.5, and then we do return depth difference. So we do fail at this one. Actually no. We fail on it here though, that's weird. Here I understand, but here, and for these points, we actually don't fail here, we fail here. Okay, that's weird. For this one right here, we fail here, I reckon. Nope. We should return 1 for all of these. Here we return black though, so it seems like... Fuck, we're returning this one. Yo, what's up, Julang? Don't give up, bro. I never will. This is... it could be this one as well. No, it shouldn't. We should either get 1 or 0.5. But we don't. What am I missing? Very interested in these points. What up? Okay. We get 0 here, but that doesn't make any sense. We return it here, that's true. Oh, what the fuck. There we go. I think. Let's see what we get. We don't want to return here, we don't want to break. Okay, good. Okay, do we have... it's pretty much the exact same result we had previously, but now we have a few methods we can reuse, so that's good. Let's see if we can do anything about the banding here. So that's when we jump down here. Do I really want to have a ray here? Yeah, we use ray a lot. Let's see. Okay, we probably want to do it like this. We don't want to store a point here, we want to store a t, or no, we want to store a step count. I think. Yo, what's up, Ominous? Bro, I would rather recommend you use cards instead of balls, because balls are throwing is patented by Nintendo. Yeah, so I've heard, We're gonna have to be real careful there. Okay, we're gonna reuse the ray, we're gonna keep step count, we're gonna keep track of step count. Point SS, fuck, I don't... Yeah, it's okay, it's okay. Okay, so smallest difference point SS, smallest difference step count 0. And here we just want to store the current step count, and that should be it. Calculate scene view depth difference for ray. We're doing SS here. So I'm just going to draw this real quick again so we can see what we're trying to do. So basically we have a point, which is the one that is closest to an intersection, and then we have one step here and one step here. So what we want to do is we know that this step is not closer. This step nor this step is closer to an intersection than this one. So what we're going to do is we're going to calculate this point. We're going to calculate this point. Will this work? Okay, this is not closer, this is not closer. So the question is, but fuck, if it depends, yeah. So we want to check which one of these two are the closest. So if it's this one, we want to do, then we do this, and we check these 2 points. So it's pretty much about taking, we take this point, we step negative, we step positive, check which one of those two that has the closest depth difference. The one that does is going to be the next point. And if we have when we have the next point, we do the same thing, but we do it with half the step direction, and we do this until step direction is 1, pretty much. So we don't want to send in step count and point. We don't want to send in step count and step direction. I think we just want to send in offset, pretty much. So float to offset. So we just do plus offset. And here we do step count times step. So what we're going to do, I want to have a safe stop still, but we're going to do and let's do I think we can do it like this. 0.A float point A depth difference point middle is going to be smallest depth difference point SS, but we don't have that one because we only do I just want to send in T here? No, I don't think so. So we don't want a step count here. We want to have smallest depth difference offset. Point middle, point B float, point B depth difference. I think this is how we want to do it. Safe stop, yeah. And then we do if I want to do it like this. Point middle offset is equal to smallest depth difference offset, and then we should be able to do calculate, actually calculate scene view depth difference for ray. We're going to do ray the first thing we're going to do here is step is we divide it by 2. And then we do point middle offset minus step point A depth difference, right? So we have the ray. This is the middle point or the smallest depth difference offset, and then we step minus step here, and we've divided it by half. So then we have point A and point A difference. We want to do the same thing but in the other direction. Middle offset plus step point B depth difference. And then we just want to do if, or actually we're going to do point middle offset is equal to, and here we check if point A depth difference is smaller than point B depth difference, then we know that point A is the new middle point. So then we return this, otherwise we return this. But I think we want to do it like this. What could happen is that the depth of this, or the depth difference of this and this, could still be bigger than this one. But we don't care about that just yet, I don't think. There might still exist a depth difference here. But does this make sense? We could actually have... Yeah, that's true. If I try to... If the depth difference is like... We could have a depth difference that is like this, right? We can make it... So that means it's this point we want to find. But this one is closer than this one. So we're never gonna find this one, or this one. If we do it like this, that is. Yeah, we definitely don't want to make too many assumptions on the depth here. Ooh. Unfortunate. I overlooked this fact. Okay, so we can't do this. But we do know that we have a peak here. Somewhere around here. Yo, what's up, Cooler? How are you doing? We're working on a reflection. It's eventually going to be a reflection file that we can just include in every shader, but yes, the end goal right now is water. Fuck, how would I go about finding this one here? Yo, what's up, Adol? How come you have to write your own reflections? Because we want to do special stuff with the outlines later on. So we have outlines in this game I want to handle. But like we could probably we could dive into or use third-party reflection solutions or Unity reflections in some way and just work around it. But we're going to do some other stuff as well. Okay. The worst part is that we could probably I guess if we want to do it like that, we could probably get a depth that looks Could we get depth that looks like Yo, what's up, friendly pyromancer? Which would return this point, but the point we want to find is actually this one. All is well, question mark? Yeah, I think so. How about you? It all depends on, if we take a look at this one. Cooler, maybe we look at the coding wizards examples. Yeah, maybe we should. Oh yeah. I don't know if he has he released one on reflection? If so, I definitely want to take a look at that one. Yeah, same here, CoolSK, but I'm subscribed, so it's easy to find. Yeah, I mean, by doing this, we would probably find a good point eventually for almost all cases. We would still have some edge cases that we miss. In fact, let's just try this and see what kind of result we get. I don't know how often we will find objects formed like this or this. We're still talking about pixel steps, so I don't know. But the question still stands is, if we take this one, we check which one have the smallest depth difference, that is the new middle point. We divide the step length and get 2 new points, and we do this until we have a pixel length of less than 1. So point middle offset so yeah, we do this and then we check I guess we can do if I don't want to calculate this multiple times, so let's do let's do it like this for now. If this is true, Let's clean this up later on. We're gonna do this. If this is true, we'll return this with point A here. Otherwise we do the exact same thing, but with point B. And then of course point middle offset is equal to, actually I want to return here as well. Is it something else? So if we find an intersection, we return. Otherwise, we set the new middle point. The next time we step through, we're going to do step divided by 2. Let's try this. Let's see what kind. Do we get an improvement here? Yeah, but not. Not that good, honestly, but and this one is extremely rough. I want to do or or we should still have while and damn, that could have gone real bad. So while this is true and or, so if the step in x direction is bigger than pixel delta, or the step in y direction bigger than pixel delta. So this needs to be true and this needs to be true. Which just gives us performance, but no... It's fucking rough, man. Yeah, I mean, it works if our step direction or step length is pretty small from the get-go. But we still have some... Or we could do... guess we could do 10, 1. I mean, it's... pretty good, and performance is good as well here. I mean, I guess the reflection here would be good enough for water. We have some... Yeah, we definitely want to base this one on distance from camera, I suppose, but... Friendly Paramancer, good job, thank you, appreciate it. But... I mean, a blur would remove a lot of the issues we see, but fuck, I don't want to add another blur. And yeah, this is a problem with array marching algorithms, I guess, the banding. It's definitely not too bad if we don't hold back. 10, 0.2. Also wonder about this. We're gonna get to this one soon. This one as well. We have a step length of 10, so it's pretty much 10 pixels. Do we actually get a ray that walks through this? Definitely looks like it. 2. I guess we could do this as well. Let's try a different second pass here. We could pretty much do this, but we do what I'm thinking is that if we step we use big steps initially to find a good point, and then we do very small steps instead of going back and forth like we did here. Because honestly, it's definitely an improvement what we did compared to this. But we should be able to get a full reflection without the banding. Kind of depressing that fuck, is this like 70 FPS for reflections like this? That's insane. Even with a pixel steps length of 1, we still get... Depends on this one as well, that's true. Could do then we get that, that's true. Still banding. But what if we do... Fuck it, let's do it like this. Step. And then we do okay, so if we do while step count 2 is equal to small step difference offset step direction minus step length times step direction, while step count 2 is less than smallest plus step length times step direction. Let's add a int safe stop as well. So while this is true and safe stop is less than, I don't know, 100, 20. So while this is true, so we jump one step back and then we do really small steps here. Here we're going to do step count 2 plus equals to step direction. Am I going to crash something now? Maybe. Ray, step count. Here we do step count 2. That's not really step count though, but yeah, let's see. Raypoint SS, do we still have access to this one? Yeah, we do. true. Let's do it like this then. We can do step count is equal to 0, while step count is less than step length 2 times step length. Step count plus plus. And then we do smallest difference offset. Yeah, I think we want to do it like this. And then we do start offset plus step count times step direction. Wow, apart from this shit, whatever this is, we're getting real good reflections here at a pretty, at an okay-ish. Where are we getting good results here? No, but banding here, that feels weird. I might know why. Fuck yeah, I know why. Huh. But I want to fix this problem as well. So what we want to do with this solution is we don't want to return this one here. We want to break, or basically we want to do this, then break. So I guess we want to do this and then break. Do we break? If we just do step count is equal to max steps, I thought this would fix this. So basically what we do now is when we find an intersection, we take that intersection point and we jump down here. But because I'm wondering why we're getting a good result on the sphere here. We're getting a very good result on the sphere. Best one yet, I think. We have a step length of 20, so that's pretty damn big. But we're getting extremely bad banding over here. And I thought that was because we find an intersection here and then we don't double check that intersection. Because actually what I'm seeing here is pretty damn sick, honestly. And a pretty damn good performance as well. So why are we getting this unnecessary banding on the bed? And then of course we're getting an intersection with the ground as well. That's not good. That's weird. Let's see. Yo, what's up, Diligence? Yes, it's going forward. Okay, a few issues here. Let's worry about Or we're getting this ground here first of all, instead of black. So that means, and the culprit for that is definitely this one. So we're getting an intersection with the, oh fuck, smallest depth difference offset. Oh, I get it. The start point is actually the smallest for this one. Oh. Ooh. Yeah, that's rough. And that's probably where we get this as well. Ooh. Okay. But yeah, that's because we move too far back. Minus step length, step direction. So we start beneath the reflection area. That's not too good. That's not good at all. But smallest depth difference. Smallest depth difference. Okay. I still wonder how this could happen. If we have a ray here. So for this one, for instance, we check if depth difference is bigger than 0. It shouldn't be for the first one. But it is for the second one. Okay. So we could do it by limiting this one so we're not behind the start point. But I don't know about that. So if start offset is now we want to do Let's do float smallest depth difference step count. Smallest depth difference step count, and then we do start step count is equal to this one minus step length, but we also do min between this one and 0. So start step count plus step count times step direction. What the fuck? Nah, max. Still have this, but this one looks very good. With good performance as well. This is pretty sick actually. Get some tiny artifacts here. If we go up on this 1, 2, 3, 4. Ooh, we get banding in this case here. Pretty damn good result actually. This one screws me over though. I have no idea what's going on here. Or why we're getting this banding here but not here. That's very weird. So we double the amount, the step length pretty much from 10 to 20. Oh fuck, did I fuck up? Yeah, I did. Oh. Is it if we divide? Yeah, if we do 0 here, but we have a safe stop here. We don't have a safe stop here. Yes, we definitely don't want to set it to 0 by mistake again. Fuck. Maybe. After that I just need to double check, are we still... Okay, let's open the project again and hope this safe stop helps us this time. So let's see if we crash, hopefully not. Okay, good. And we have a safe stop at 50, that's why we're getting such a bad result here. That's okay. 5, 10. Do we actually have 500? So what do we have? 10, 0.01, 20, 10, 5, 0.5. Oh, that's way too much. 0.1. Okay, that's roughly the result we had. But yeah, this banding here, I find it... Actually... It's just a different type of banding, pretty much. Definitely getting some weird results here, I would say. So this leg issue we get here, I think it has to do with, let's see, 10, 15. Yeah, I'm pretty sure what happens is that the first point, the reflection point, is always going to be the one with the smallest depth, because but yeah, could that be the case? We only care about depth differences that are bigger than 0. Yeah, it could be. So with a step length of 20, we probably will reflect on the ground, and then one step here. This is the smallest difference. Okay. I guess that's the problem we get with the banding as well. So what can we do about that? So let's see if I can draw it to make some sense. So pretty much we have our reflective surface here. We have a pretty thin object here. We shoot a ray that goes like this pretty much. If I want to visualize it, we're probably gonna have to do like this. So what I think happens is we check the depth, the intersection on this one. We get a negative difference here, so this is not the closest one, or the one with the least depth difference. Then we check here. But this should still be now this one should still be. Oh, no, I don't get it. I was wondering if, yeah, so we step through this full one. So we're gonna there. If we don't find any, yeah, let's see. Let's say that's the case. We don't find any. That means that the smallest depth difference is, it's this one. Yeah, smallest depth difference offset is 0. That's probably what's happening here for this leg. So we actually have a ray. And this one hits this one, but it doesn't hit the leg. So yeah, you definitely don't want to go. Or actually, do we get? We don't even get it with a step length of 1. That is interesting. But do we get it with a step length of 1 if we don't do this? No, we don't. Fuck. Oh. Yeah, we hit here. Yeah, and then it's this one. But we're far behind it. So we just take this one. Okay. So, yeah, okay. Now, I don't know if that makes sense. We should still be able to get this tiny part here. With this second pass, why are we still getting bandings like these? ...200 FPS... ...this result... Okay, I think we had... I'm just gonna have to check this out. I think we had... not this one, I don't think. Didn't I save that one as a bookmark? Give me one sec. There was a very good discussion about screen space reflections on the Unity forums. Let's see. Screen space local reflection. Yeah, I think it's this one. Let's just see if I can get some good ideas from this one. Would love to see this without the water offset. Yeah, exact same thing. Mm. 256 steps per ray. That's pretty much worst case. That's something similar here. Yeah, that's pretty much what something similar we do right now. But yeah, this I'm very interested in as well. Not this one, but this. Jitter fraction. I'm very interested in what exactly Mm. This, I think, would be very helpful, but that would also mean that we would have to create a custom depth map, and I don't want to do that. Mm. I would like, if we use incredibly small steps, we lose a lot of performance, but the result is beautiful. And basically I want to, we already have it split into two passes, one quick search basically and one more detailed search. So quick search finds a, let's see, ray portion of interest, and then we do very small steps on that one. But I think looking how much the result degrades, so at a step size of 5 we start seeing banding artifacts over here. It feels like we could either improve, I think we need to improve the first search. I mean, this is not too bad. These banding artifacts is something you would see being reflected on water as well, so that's okay. But I mean, yeah, I think we can improve the first search, because the first search shouldn't be finding, like it finds the perfect pixel here, but here it doesn't. What could cause the first iterations to not find? Yeah, that's weird. Maybe we want to do, it could very well be that we end up in front of something, and that should be our, so if we do, yeah, that's not what we want this one to find. So what happens here? Smallest difference offset. Okay. $192, that's not too bad. But what if we do... We get depth difference here, and then we do... Okay. Yeah, this one worries me. So, yeah, we still have a problem with finding reflection points in the wrong direction, basically. So we find an intersection too early, and that's because we do the apps here instead. I think. First search. We probably want to fix this one for the first search as well. For the first search we want this one to be quite big, but not big enough for this to happen. Still not entirely sure why this would happen though. Step 10. This I find very interesting. So, step length of 1. What point does it find such that we just return black? It has to be the first one, but that shouldn't return an intersection. Unless we're getting screwed by this one, but I don't think so. Step count 500 now. We should still walk 500 pixels. So it has to be that we find something here. Smallest different offset. Step count, step direction. Return 1, 2, 3, 4, 5. Ooh. 6, 7, 8, 9. attempt. We actually get a very good result here. $15, $25. Okay, this is where we start to screw up. $25, $1, $2, $1. Yeah, steep angles sucks. That is one of the problems we have. Steep angles. Ooh. Yeah, we always move 1 pixel. At least 1 pixel. And on steep angles that might be a lot. That is true. Is that the problem we're having? Maybe. Let's see, let's do it like this. Float 4. So red pixels are pixels we find in the first iteration. Those look pretty damn good, honestly. Still hate the fact and if we find one here, we're gonna do return blue. So red ones are first iteration, blue ones are second iteration. We're at 200 FPS. That's good. That's what we want to go with, or where we want to be around. At least. So we can see here that the second pass helps us quite a lot when we have steep angles, but not enough. And still this issue. Okay, if this is probably the issue, the artifact I want to fix the most. Like, I would be okay with these artifacts if we could avoid these artifacts, but the question is, are they connected in any way? Why we're not finding any intersection here but here? Even though these are false intersections, we're pretty much seeing the back side of the object in question. I don't care too much about that though. And also, where we're getting hell, or yeah, this is exactly the same. We're finding this one, but not this one. It's a false one as well. Or is it? No, it's not. It's actually this we want, because it's this one. Smaller step length fixes it for us. I think we need to base step length on... Yeah, because the fact is... Okay, I think the biggest problem we're facing is that we always move at least 1 pixel in any direction. But 1 pixel might be a very small value on the view ray, but it might also be a very, very big step. And if it's a big step, that's when we miss stuff, because then we're going from... Then the jump in depth in view space is very large. So we this is probably what I'm missing. We want to check... how could I miss this? We pretty much want to do... When we follow the ray in view space, we want to keep the last depth value we had, and we want to keep the new depth value we had. And when we compare depth, we want to see that, so the object in screen space we will compare with, we want to check if it's between these two depth values. We pretty much want to take... We don't just want to compare with 1 depth value, we want to compare with 2. I think. I think that would help with these issues. Definitely 20. I think these issues. But I wonder if I think I get it. Depth difference not enough. We can probably solve it in... Or I wonder... Or could we walk one step. Yeah. We have the ray. We walk one step in screen space. We get this point in view space, but what we do is we actually get 2 points in view space and check if the depth here is within this depth. So if this depth is maybe get 2 depth values, figure out which one is the biggest one, which one is the smallest, and then we take the smallest minus threshold, and we take the biggest and do s plus threshold, and then we check if let's call it P. If P is within this, then we have an intersection. But how would that work for? It would probably work quite well for rays that are aligned with the pixels. But for rays that are not, for instance, we could have a screen space ray that goes like this, and we could have a view space that is pretty aligned with that one. That means that we would probably have to calculate how aligned they are and figure out, base this step on it. In fact, I do want to try this at least. So what do we have now? We're gonna skip second pass, which yields this shit. And then we're gonna do calculate scene view difference for ray. We're just gonna return think we don't use stride or jitter. In fact, let's use jitter for now. So calculate scene view depth difference for ray. In this case, I don't think we would. We just care about if it returns true or not. Maybe. So it would pretty much be. Then I wonder if we're gonna have. Let's worry about that later. But let's do. Point A depth vs point B depth vs and then we do T minus jitter, T plus jitter. Oops. And then we need to do if point B depth vs is less than point A depth vs so point A is always the smallest one, right? And then we read this one. And then we do we don't care about this one. But we return depth, or point A depth vs is less than or equal to scene depth vs, and scene depth vs is less than or equal to point B depth vs. But here we want to do plus threshold. What do we call it? We call it thickness. Thickness based on distance. Let's just go with thickness. And this one is actually, this one is minus thickness and this one is plus thickness. And so yeah, then this doesn't work anymore, but if calculate in fact we still want to do those checks though, so let's just return depth difference is equal to this and return true. So depth difference is 1 or 0. If it's 1, or we can just do if it's bigger than 0. So we do this here. Yeah, we do this. Return depth difference is bigger than 0. That's not true. If depth difference is bigger than 0, return 1. Otherwise we just continue until this one returns false, I guess. Okay. Said thickness. And then we have jitter as well, yes. 0.1, 0.1, 0.1. Do we have this big of a... Yeah, said thickness we want to be a little bit more 0.1, 0.151. Can we find some good values here? 0.05. Okay, the higher we go here, 0.1, 2, 3, 4, 5, 6, 7, 8, 9. Am I calculating the offsets wrong here? So said thickness. Oh. Here we want it plus thickness. Pretty good performance, same artifacts, but that might very well be because if we do 10 here, yeah, we get this artifact, that's not good. Jitter remove extremely... Yeah, this one I need to figure out. Yeah, I think it's because we go between 0. Yeah, definitely. So we need to check that as well. But I think we might be onto something here. 2, 3. Yeah, definitely. Definitely 4. 2, 3, 4, 5, 6. So what I want to fix here is max between 0 and this one, because we don't want to go underneath. Fuck, I thought it was. Definitely thought that was the case for this one. Because I'm afraid that we go... We could also saturate this one, I guess. But is that really... But then we get minus thickness, so we still end up underneath. I think that's what's happening here. Jesus, we're having an extremely good performance here. Wait, yeah, we have... The artifacts are... Yeah, we want to have... Do we care about jitter? Maybe we don't. Way better performance, same artifacts, I would say. And if we do jitter, not that much. We can get some, we get some artifacts like this, but I wonder if... We have this as well. If we can get rid of this artifact, I think we would be... I'm okay with... Ooh, this is rough. This is rough. But I'm pretty sure... Yeah, so let's worry about the white panel we're getting here first. 220. If we do with 20, we can probably go with 0.6. Yeah, if we can fix this one, that would be beautiful. 3, 0.01. But let's see. 6. Said thickness, if we make this one bigger, we get this issue. I don't want to saturate here. And then it's worse, yes. I still think we want a positive scene depth difference, so I'm wondering or fuck, in this case we might not care. Yes, we need if we take the first point here, we move in the direction of the... Nah, I think we want to saturate here actually. But it's weird that this doesn't fix this issue. This one. It fixes it a bit, but... because that means that this depth it could mean that, or actually by saturating this we know that this one we never move backwards from the start point. So but we do negative here. So this one can still end up... Oh, that's true. Yeah, so I'm pretty sure... yeah. This depth turns out to be less than whatever we have under the reflective surface here. So I guess we could do... Just to check if this is true. If t minus jitter is less than 0 or bigger than 0. If this one is 0, we get a negative value here. This one is 0. So we just take this depth, and this should not be true if this issue is what I think it is. So this should be equal to whatever depth we have here, and that depth should... fuck, that depth is smaller than this one. That's true. Because we're closer to the camera. Is this the comparison we want to do? This is the reflective surface. This is the first viewpoint. This is the direction. We have something underneath here. So if we have, if this is the viewpoint, so for the first point, we take this point, we try to move backwards, we can't, so we have this point, then we move forwards a tiny bit. So that's the 2 points we have. This depth is, it's actually, this is the point behind. This depth is bigger than this depth. So we should be returning false here, or black. This depth is also bigger than this, or this depth is bigger than this. Ooh. Is my comparison correct? If point B is smaller point A, yeah. So if we have an object here, get this point, then we get this point and this point. This depth is bigger than this depth, and this depth is bigger than this depth, fuck. But that depends on how big this movement is. This should be correct. So what is with this artifact here? If we take thickness, thickness is 0, 1. Should be able to get a very good result with this. If I could get rid of this. Oof, 250 FPS with screen space ray marching, that's acceptable. Definitely. This one, thickness adds the artifact, Stride adds if scene depth is bigger than, okay, so this is basically if point A is closer to the camera than scene depth and point B is further away from the camera than scene point, then we're intersecting something. Doing the subtracting thickness here and adding thickness here might mean that we get some intersections that we don't want. Subtracting jitter and adding jitter here, but we saturate this one, so we never go outside of the ray. So I think this is good. But yeah, we get the depth of the reflective point and then we subtract depth from it, which means that it's smaller than this one, definitely. I tried adding a, if this results in a point that is, we basically want to avoid honestly, if we just skip step count, where the fuck do we have step count here? If we just skip the first step, do we get rid of the artifact in question? We probably lose, I think we lose these reflections as well. And here it looks sorta good, but then we get, here we get this artifact instead. But does this mean thickness? Can we go way higher in thickness without getting back the, here we get it again, that's 0.06 step length 20. Yeah, I guess it depends on, looks alright, but then we have this artifact as well. Yeah, we're gonna have to base thickness on I think the problem here is that the screen space ray and the view space ray are pretty much aligned. So moving 0.05, let's see, 0.05 times 40, oops, 0.05 times 140. Yeah, what the fuck, we move 72 pixels. Let's assume that they are totally aligned, so we move 72 pixels when we work with thickness here, and that's 72 pixels. Still shouldn't result in this bad of a artifact, I don't think. And this is when we have rays that are aligned with the view point pretty much. So this is where we should move a lot. Yeah, we want to do dot product on the reflective. We want to do dot product between the reflection vector in view space and the view vector. And the bigger and then we want to take that value and we want to multiply it with said thickness, I think. So in this case we would have 0.05, although it doesn't, it helps. In this point we might actually go even further. So for this, but in this case we would have is this a problem of jitter? Yeah, maybe we want to get this one in on it as well. Probably. Fuck yeah. Yeah, we do. So here we want to avoid big values, but here we probably want to have big values, yes. And this still leaves us with some banding artifacts. That's not good. But 250 FPS here, that's very good. If we were to reduce this one as well. Yeah, if we could refine this, I think we got it. Pretty damn good. I want to check one thing. So if we do return dot between ray normalize ray dot normalize ray start ss no end ss minus ray start ss. And here's the problem, we don't care about the sed, so we're gonna do normalize ray end vs minus ray dot start vs, but we only care about xy here, I think. Xy here. And also I think we want to add a minus sign here. I just want to see. Dot, that's between 1 and minus 1, right? So I want to do plus or times 0.5 plus 0.5, right? Minus 1, 1, minus 0.5, 0.5, yeah. So 0.1 or 0 to 1 instead. So this one I'm pretty sure this is what I want to see. So imagine a ray here. It's pretty much aligned with the view. But so one sec, what do we have? Do I remember correctly? Dot product. If it's 1, they are perfectly aligned, right? If it's minus 1, they are pretty much the opposite. Is that true? Fuck yeah, I think not really. Or actually, I think it is. Yeah. But what about this one? I wouldn't say it's totally opposite here. I was thinking would be seeing 0.5-ish here. Or am I misunderstanding something? Yeah, 0.5. I would reckon we would get 0.5 here. Am I missing something? This I buy. I'm gonna have to explore this one a bit more, but it's basically gonna be used as a. It's gonna be used to control how big of a jitter we're gonna have. I'll need to rename this one as well. So the more they align, the less we want this one to be. Yes. The less they align, the more we want this one to be. But that's not entirely true, I don't think. We want to calculate the ratio between. In fact, we already have this one, don't we? Yeah, we do. So I want to calculate the ratio, or we can calculate it pretty easily. We don't need to include dot product, but we might need it for something else. We'll see. Like, how much does moving 1 pixel or 1 step one step in screen space, like what is the ratio there? Is it roughly the same distance, if you could compare it like this, or is moving 1 pixel in screen space moving a very long distance on the view space ray? Yeah, that's what we want to figure out. Unfortunately, I won't get to the bottom of this today, but I think we have made very good progress. First of all, we have a pretty good result. We could probably run with this one. It's a little bit performance heavy, but with this one, and then you have the movement of the water or whatever we're going to reflect the surface of the reflection surface, we can pretty much hide most of the artifacts we still see here. But I really believe in this solution. We just need to figure out the relation here. Hopefully we will get to the bottom of it tomorrow. But I gotta run now, so thank you so much for watching and have a great rest of the day. Peace.